Okay, in this video we're going to look at solutions to 2025's A-Level Mathematics A22 module, and this is the applied module. It has a mechanics part and then a statistics part too. On the first page, read the instructions. You have 1.5 hours. Answers are given to 3 significant figures unless told otherwise. Total for the paper is 100 and G is 9.8 unless they tell you otherwise. Okay, first question. I have done this out already, so hopefully won't be too many mistakes in this. It says acceleration A, meters per second squared of a particle at time t is given by A is equal to 4 over 3 t cubed I minus 5 t squared j. Find the acceleration of the particle when t is equal to 3. So I would just say here when t is equal to 3, and we're just subbing 3 into this thing. So your A is going to be equal to, it's a vector remember, 4 over 3 times 3 cubed I, and then minus 5 times 3 squared, and that's going to be j. If you did that out, 4 over 3 times 3 cubed, which is 27, that's going to be basically 4 times 9, that's going to be 36i, and then minus 5 times 9 is minus 45, and that's j, and that's meters per second squared. Done. There's 2 marks for us, I think it was, 2% already. Next one says the particle has a velocity of 6i plus 2j when t is equal to 0. Find the velocity of the particle when t is equal to 3. Right, first thing we've got to do is get the equation for your velocity, and your velocity you get is by integrating your a with respect to time. So the big thing here is you have displacement, velocity, acceleration. To get this way, you differentiate with respect to time, and to go this way you integrate with respect to time again. Okay, so we want to go from acceleration to velocity, so we're integrating. So we want to get our velocity. Our acceleration was wherever it was this thing here. It was 4 over 3 t cubed I minus 5t squared j. So we want to integrate that then. So it's the integral of 4 over 3 t cubed I minus 5t squared j, integrating that with respect to t. So when you integrate it, you're going to get, that's going to be 1 over 3 t to the 4, 1 over 3 t to the 4 I, and then that's going to be minus 5t cubed over 3j plus some constant of integration, and that's a vector constant. All right, now I'm going to write this a wee bit differently. I'm going to write this as a column vector, just because that's what I prefer to work with. That's 1 over 3 t to the 4, and then minus 5t cubed over 3, and then plus my constant of integration. Now we're told, you can just about see there, when t is equal to 0, your velocity is 6i plus 2j. So we'll just say t equals 0, v is equal to 6,2, and that means a wee bit of working out, that means your c is going to be equal to 6,2. Now write your v again, and again I'm going to write it in column vector form. I'm going to squeeze the c into it. So 1/3 t to the 4 plus 6, and I'll write that then this time as minus 5 over 3 t cubed, and then plus 2. So there's what my velocity vector is. Question asks me to find the velocity when t is equal to 3. So just say again, when t is equal to 3, your v is equal to, and firing those into that, that's going to be 1/3 times 3 to the power of 4. That's going to work out to be 27, and then plus 6, and then 3 to the power of 3, and then times, multiplied by minus 5 over 3, which is minus 5 times 9, which is minus 45, and then plus 2. So my velocity is going to be 33 minus 43, and because I had given it in ij form, I would just be a wee bit wary of giving it in column vector form. Definitely like to work in column vectors, but give my answer back in their form. You may notice I sometimes use this as my units. If you prefer this, that's absolutely fine. They're both correct, whichever one you prefer. Generally, people who do physics prefer ms to the minus 1, and same for acceleration, ms to the minus 2. Next one is a momentum question. Two particles, C and D, have masses 4 kilograms and 6 kilograms respectively. They both move along the same straight line in the same direction. C has a constant velocity of 5I plus 4J, so vectors again. D has a constant velocity of 7.5I plus 6J. D catches up with C. D collides directly with C and they coalesce, which means they stick together after the collision. Right, so D is behind. I did this first time, I made a wee mistake. I had the C chasing the D, but it was D is the one that's trying to catch up. There's my very, very good diagram. So just two circles, and the velocity of the first one was, what was it? It was 7.56 meters per second. The velocity of the second one, the C, was 5.4 meters per second. And after, so that this is the before diagram, and then we're using the after diagram. The after diagram, just have them both together. So the combination of them is 10 kilograms, and they're moving with a common velocity. And it's a vector. I had a vector in mind, I should have had. That's a vector technically. Okay, what we're using here, folks, in this one is we're using the fact this is what's called conservation of momentum. So momentum before equals momentum after. That's what we're doing. Whether or not you get a mark for writing this down, I don't know. But you might do, so I would just always put it in just in case. Now, the momentum before, I've got I'll do the D first, the C first, the 4, it's mass times its velocity, which is 5.4. And then the D, which is 6 times its velocity, which is 7.56. And the momentum after is just going to be 10V. Sort that out on the left-hand side. 5 times 4 is 20, 6 times, let me just check, 6 times 7.5 is 45, and then plus 20, that's going to be 65 on the top. Then 4 times 4 plus 6 times 6 is going to work out to be 52 on the bottom. That equals 10V. A little bit of working out then, my V, I'm just doing this here so we can just see it on the one screen. My V then is going to be equal to 6.5, 5.2. My V then works out to be 6.5I plus 5.2J, and that's meters per second. Next bit says, find as a vector the impulse on C. What on earth is impulse? Impulse is force times time, but that's not going to work in this case. It's also mv minus the mu. So we're going to look back at our C. You can see there's C, and C itself, this bit here, if I write this in now this time, that was our 6 kilograms, that was our 4 kilograms, that was a C. So it started off at 4, as 4, a mass of 4, finishes with a mass of 4, that doesn't change. And its initial velocity, the U, is 5.4, and the V, we have just worked out to be, I think it was 6.5I plus 5.2J, it was indeed. So our impulse, let's just fire these things in. Mass was 4, the final velocity was 6.5, and then 4 times my initial velocity, which is 5, final velocity, my mass times the initial velocity, which was 5.4, and when we just do that, I have got 6 and then 4.8, and the units are going to be Newton seconds. So again, that's 6I plus 4.8 J Newton seconds. Let me just check my working out here for these ones there. 4 times 6.5 minus 4 times 5 is 6, and 4 times 5.2 minus 4 times 4 is 4.8. Yep, good. Another 2 marks. Okay, projectiles. Right. This, folks, is, you really need to know how to be able to do these. These are this is on your this is on your specifications that you need to be able to work out your equations of trajectory, if I could speak. So they've sort of given you this, but also I would, instead of really learning the equations, I would be very wary of doing that. I nearly think you need to understand what's happening in the proofs. So, and the reason for that is prime example here, instead of calling the initial speed u, as it would be in quite a lot of people's notes, I'd imagine, they've called the initial speed 60. So if you don't understand, you just learned it with a u in it, this will throw you. So you need, understanding is where you need to get when you're learning and you're revising. So a projectile is launched from a point A on a horizontal ground with an initial velocity of 60 meters per second at an angle alpha to the horizontal, as shown. Show that the range of r of the projectile is given by this. Okay, right. You might do this and you might waste a wee bit of time, because maybe what you're doing, you're taking yourself down a road which is not going to get you anywhere. But have a go. Just get started. There's only two things you can do here, which are going horizontally and going vertically. All right, you've got to split it into two bits. But the key thing about projectiles is the horizontal speed, I'm going to say, is the same throughout. So whatever the speed is there at the start, it's going to be exactly the same here in the middle, and it's actually going to be exactly the same at the end. Okay, so that is because we have done what's called mathematical modeling. We said there's no air resistance, so the speed, whatever speed it's chucked at the start horizontally, it's going to stay. The vertical speed changes because it's moving vertically and you have a force vertically, which is our force due to our acceleration due to gravity. So let's just go say horizontal, and my initial speed there horizontally is 60 cos alpha, and then my time is just time, and my distance is equal to r, and we're just going to use distance is equal to speed times time. We're using that because, as I said, there's no acceleration, the speed's constant. So in this case, r is equal to 60 cos alpha times t. Now, it doesn't look like it's done me a lot of good. I'll see later on if it'll help me. I don't know. Okay, right. What else we got? That might well work for me, might not even use that at all, don't even know. Right, so vertically, if I go in the vertical, my initial velocity, so going upwards here, I haven't got the angle, so it's sine, so it's 60 sine alpha, and then so that's, use the arrows here, that's upwards. My acceleration then is minus g upwards, it's going against that if it's going up. My velocity at the end, so when I get back down here, my velocity, because of the nature of the symmetry here, if it's going upwards here with a speed of 60 sine alpha, it's going downwards also with a speed of 60 sine alpha. But as a vector then, that's minus 60 sine alpha upwards. So I've got all my arrows going the same way. My t, I'm looking to find. Okay, so we're going to just say v is equal to u plus at, and here we'll say in this one minus 60 sine alpha is equal to 60, zoom in on this wee bit, 60 sine alpha, and then that's going to be minus g times t. A little bit of working out, bring the gt across, make it positive, and then bring those two 60 sine alphas to one side, that'll be 120 sine alpha. And then we will say our t then is equal to 120 sine alpha all over g. Okay, now I've hit a wall. What can I do? What can I do? We can just fire that back into the r. Okay, so we'll call that equation 1. So just say sub into equation 1. So fire that into my equation 1. My r then is equal to 60 cos alpha. Instead of my t, I'm going to write 120 sine alpha all over g. And then we'll go from there. Again, folks, remember, you never do what I'm doing here, writing over these things. This is just to keep us on the screen for your benefit here. And make it a wee bit easier for us to see. But you would never write outside that box, as that's the only bit that gets marked. 60 times 120 will be 7,200, and then that's going to be, I'll write it as sine alpha cos alpha, and then that's all over g. And then remember that 2 sine alpha cos alpha could be replaced with sine 2 alpha. So here on this top line, you could then write that as that's going to be 3,600. So I've replaced a 2 and I'm replacing sine alpha, cos alpha with sine 2 alpha. And there we are, have it. And that's all over G. I think that's what we're looking for. It was indeed, go me. 6 marks. Not easy, but certainly very nice. I enjoy all those sorts of questions. Very nice. Now, we're going to use that again. Let me just write that down again. What was it? What did it say there? R is equal to 3,600 sine 2 alpha over G. Okay, it says the range of the projectile is found to be 350. Calculate the possible values of alpha, correct in the nearest degree. So just fire that in. The range is 350, is 3,600 times sine of 2 alpha. And also our G, we know, is 9.8. Let's bring those across. So what I've done in this next line, I've multiplied across. I'll just show my working out here. What am I doing? Multiplied across by the 9.8 and then divided across by the 3,600 to give me sine 2 alpha. Let me just check that. 350 times 9.8 and then divided by 3,600. And that gives me a perfect answer. That sine of 2 alpha is equal to 343 over 360. Okay, right. Oh, I'm run out of space. Don't write as big as that, please. Right, so that's what you've got. And then you will say, then you would do your basic angle, do my basic angle here. So shift and sine of that, and I'm trusting I've got this right. That was 72.32 I got. If it's not, please adjust that. Just check, you should be checking these as you're working through this. And then sine is positive. It's a cast diagram question now. It goes in here and here. So, here. I actually used a lot more decimal places, we've just realized there. Just because I'm going to be dividing. So 3.219, so 72.3219, 72.3219. Okay, just to keep the accuracy. So my first angle is, there's my 0, so it's round to there. My second angle is here. So that was what 2 alpha was. 2 alpha was equal to 72.3219, or 2 alpha could be 107.6781. That means alpha is equal to 36.2 degrees. It was the 3 sig figs, wasn't it? And 53.8 degrees to 3 sig figs. To keep the accuracy there, there we have it. Lovely. So there's 2 possible answers. Right, so what this means, just to show you what we're actually talking about, basically for this to go, whatever the range was, what did I say the range was? 350. I'll just do it here. You could have, there's 350 meters. That's what my range was. You could have fired it off at a low angle. You could have fired it off at a slightly bigger angle. Okay, so that's what that means really, the 2 angles of projection. Super. Right. It says, find the value of alpha for which the range is maximum. You should know really that the range is maximum when at the angle of 45 degrees, but I think for 2 marks they want us to show you this. So the range formula was here. Let me write it down again. Range was equal to 3,600, sine of 2 alpha all over G. The range will be maximum at 45 degrees, but that is because the maximum value of sine is 1. So I'm just going to say R is maximum when the sine 2 alpha is maximum, i.e. that means when sine of 2 alpha is equal to 1. That's a maximum value that sine can be. And sine is maximum when the angle is 90 degrees, i.e. alpha is equal to 45 degrees. So that's really almost like a proof of why the angle is maximum. So if you're playing golf or something like that, and you want to hit something at a maximum thing, your initial maximum range, your initial angle should be 45 degrees, okay? And if you have played golf, you probably know, aim something too high, comes down, quicker, sorry, comes down in a shorter range, and aim something too low, it'll come down as well a bit quicker. So 45 degrees roughly is the thing. In the real world, folks, you have other considerations such as wind and also air resistance would come into play, but wind would be a big one. So I'm not a golfer, but I would imagine if you hit a ball higher in the wind, it might veer off. So that might be a reason somebody would want to hit it with a lower club. I don't know, and I don't care. Don't tell me in the comments. Right, the next one. It says a particle's motion along a straight line is modelled such that velocity v at a time t is given by v is equal to 5 cos t. Bear with me a second. Oops. So v is measured 5 cos t pi over 2t. Find the times at which a particle is instantaneously at rest for the first time. So instantaneously at rest in the first 4 seconds of motion. So you put v equals 0. So v is equal to 5 cos of pi over 2t, and then that just becomes another wee trig question. Tough enough we examine this. Like if you didn't know your basics from your pure, you could be in diffs. Okay, so here cos is equal to 0. Find one of these. So cos is equal to 0. Note we're going to be using differentiation here. So we're going to have to do this in terms of radians. Now the clue is in this as well. So as well, we're going to change our range. It was 0 to t to 4. Now if you multiply that by pi over 2 times t, pi over 2 times 0 is 0. Pi over 2 times 4 is 2 pi. Alright, so pi over 2 times 4 gives you 2 pi. So we're really doing this. You can sort of use your cast diagram for this. So if you did just cos the minus 1 of 0, and if you did cos the minus 1, shift and cos of 0, you get 90 degrees. And in radians then, so pi over 2t is equal to 90 degrees, that's pi over 2. And if you think on a cast diagram where that is, that's going to be here. So it's also going to be equal to 0 in the opposite place, and that would be 3 pi over 2 radians. So that means your t, just divide across by that pi over 2, you're going to get 1, and you're going to get 3. So your answer, t is equal to 1 second, and t is equal to 3 seconds. Okay. Next one says, find the distance travelled by the particle in the first 3 2/3 seconds. I've just done a wee video with that a while ago, a few weeks before the last exam there, giving your answer in terms of pi. This is a tricky version of this because it's got this trigs thing involved here. Now, hopefully you got these because you need these for the next bit. What you've got to do here, don't take us down just yet, but you've got to find the time at the start, the distance at the start. So when t is equal to 0, you've got to find out what the distance was. When t is equal to 1, because that was my first time at rest, you've got to find what the displacement was, I should say. When t is equal to 3, what the displacement was. And then the last one was when t is equal to 3 2/3. And I've just realised I haven't read the question. I did 4 instead, so right, I've got to be careful of this. That has to be my 3 2/3. So that's what we need to do. So find the displacement at those times, and then we'll find the difference between each of those and add them up. Because what could happen, this thing starts somewhere, it goes out for 1 second, and then it stops, so it must change direction, goes out. For another couple of seconds, so t equals 3, it stops, and then it goes on. So you've got to effectively find this distance, and this distance, to allow you to find the overall total distance. So we have a wee bit of work to do first. First thing you've got to do, we've got to integrate our v to give you your s. So if you integrate your v, it's going to be it's going to be 5 sine pi over 2 t, and we're also dividing by pi over 2. I'm just going to do it that way, and then plus your constant integration c. So my S works out to be, that's just going to be 10 over pi sine pi over 2t, and then plus c. Now read the question. It doesn't tell you a particle motion along a straight line is model such as velocity at t seconds is given by, and it doesn't tell you where it starts, and doesn't give you any indication of how you find out where it starts. So in this situation here, you got to just assume that t equals 0, s equals 0, therefore c is equal to 0, which tells you then your s is just equal to 10 over pi sine pi over 2t. All right, so that's what we're working with, and then we're going to have to put these in. So when t equals 0, my s equals 0. When t equals 1, I'm going to just put these in here. Okay, what was it? 10 over pi. So you're putting this into your calculator well once. So 10 over pi, and then what was it? It was sine of, and then pi over 2, and then I'll just put in the times the 0 first of all, just to check, and that is 0. And then you're putting the 1, so I'm going back in and editing the 0 to 1, and I got to whole pi the decimal places 3.1831, and then put in the, what was it, 3, and put in 3, and I got minus the same 3.1831, and then put in 3 and 1/3. 3 and 1/3, 3 and 2/3, sorry, 3 and 2/3, and this is where I would have had my mistake there. I had put in 4 for some reason, so read the question carefully. So there we are, we've got those all the 4 decimal places. So what you've got to do then is work out the distance from 0 to this. It's going to be 3.1831. From this one to this one, it's going to be 6.3662. And then from this one to this one I need to do, so what's that going to be? 3.1831 minus 1.5915, and oh, that's 1.5916 it gives me. And then my total distance, again I'm writing all over the place here folks, but just so we can see it on the one screen. It's very hard when I'm going back and forward. Your total distance is equal to, and then we'll add those 3 things there. So this, and this are now getting added. That's my total distance, 3.1831 plus 6.3662, and then plus 1.5916. I'll just do those very quickly. 3.1831 plus 6.3662 plus 1.5916, and that is 11.1409, and we'll say to 3 sig figs, that's 11.1 meters to 3 sig figs. There we go. Okay, you can see it, plenty of space to do all of that. Here we go. Right, we're on to, I think this is our last of our mechanics questions. Yep, it is tricky enough. Moments question. A lot of people come out, they did not like this one at all. It says, figure 2 below shows a non-uniform rod AB of length 10 and mass 12, which is hinged at end A to a vertical wall. The rod is held in equilibrium by a light inextensible string, BC, with C attached to the wall vertically above A. The string makes 90 degrees with the rod at an angle of alpha theta to the wall. Center of the mass is root of the rod is located at a point D on the rod where AD to DB is 2/3, and the magnitude of the tension of the string is 42. Right, let's mark on what we can. There's our string, that's 42. There's our, what we've got to do here is complete the diagram showing all the external forces. I would also sort this out. So the mass of this rod was 12. The length of the rod was 10. So that is 12G here going down. And this wee length here it's divided in a ratio of 2 to 3. So 2 to 3, that can be scaled up, multiplied by 2, that's going to be 4 to 6, and they add to give you 10, so there's 4 and there's 6, whatever way you want to do those ratios, do them. So that's what we've got, but we've got those wee distances which we'll need. Okay, right. I'm also going to mark on the force from the hinge, P, and I'm going to do it at an angle alpha to the vertical. This isn't very typical of the way I would normally do these, but it's just because it's a bit awkward having it drawn on anywhere else. So I'm just marking my P on that way this time. And also, right, let's have a look at this. This angle here is theta up top. That means this angle here, all the way down here, would be 90 minus theta, which means this angle in here is actually theta. All right, so you've got that as angle theta, which means this angle here is also going to be theta. Now, we're also told, no, we're not told anything else just yet. That's it. That's all we've got. I think that's us done. What I would also do then, if that angle is theta in here, this angle is going to be theta. So if you're going vertically, this force is 42 cos theta, 42 cos theta. Right, there's your diagram. Give you a minute to digest that. Does it tell us anything else? Nope, not yet. Okay, right. It says show that cos theta is equal to 25 over 28. I'm going to do this over here where we've got my diagram. So this is part 2. Basically, we've got to find out what cos is. Right, there's only 3 things you can do here. You can take moments, and typically take moments about the hinge, and you can resolve vertically and you resolve horizontally. So there's the 3 things you can do. So take moments, and then resolve vertically and resolve horizontally. All right, there is nothing else you can do in these questions. That is it. So that's all you can do. So you may not have a clue what you're doing, but if you do those 3 things, you're going to get a whole pile of marks. All right, and then hopefully, and this is what mathematics is all about, hopefully something sparks once you've done that and you think, oh, here, now I know how to get on to the next bit. But you should know your notes well enough to know all I can do, resolve vertically, resolve horizontally, take moments, and then go from there. So we're going to take moments about, this is my part 2, by the way, just doing it here that I can see my diagram, and I'm taking moments about A, and I'm doing clockwise equals anti-clockwise. This is very difficult to see on the screen, but the reason I'm taking moments about A is this horrible force here, P going at an angle alpha, I can forget about it because it acts through the A, right? The reason for that is if you imagine a seesaw, you have a boy sitting here on a seesaw, you have a bigger boy sitting here on the seesaw, and you have this guy in the middle. He has no turning effect because he's acting through the pivot. Same idea, we're pivoting about A, P acts through A, so it had no turning effect. That is it. Right, clockwise. Right, clockwise, we've got to make the things at right angles. So there's clockwise. You have got 12g cos theta equal to, times 4. That's the only clockwise force. Okay, anti-clockwise. This one's pulling me anti-clockwise, and it is 42, and that is going to be just 42 times 10. 42 times 10. You don't need to pull the angle any direction. 42 times 10. So then let's work with this then. That means cos theta is equal to 42 times 10 divided by 12 times 9.8 and times the 4. And if you do that out, you will get 23 over 28. Please tell me that's what I'm looking for. Oh, sorry. Let me check this. Sorry, I think I can't read my own handwriting. I think it is 25. Let me just check that very quickly. 42 times 10, and then divided by 12, and divided by 9.8, and divided by 4. Yes, sorry, it is 25. Thankfully, 25 over 28. So that's what we're looking for. Okay, right. It says find the magnitude and direction of the reaction at the hinge. Now, to do this, we want to find the magnitude and direction of the reaction at the hinge. I'm going to keep this on the screen again. So this is my part 3 really. I want to find the magnitude and direction of the reaction at the hinge. Okay, right. Before we do anything else, they've told me that cos theta is equal to 25 over 28. If you do it this way, they don't really want you to find the value of theta. So just let's see what we're going to do here. So cos is equal to adjacent, so 25 over 28. Now by using Pythagoras, you can work this out. So that side there is going to be the square root of 28 squared minus 25 squared. And when I did that out, I got a not too nice answer, but I got the square root of 159. That's perfect. And then that means, therefore, sine theta is equal to opposite, square root of 159 all over the hypotenuse, which is 28. Okay, right. Now we're going to use that. And what we're going to do then is we're going to just, from this, we're going to resolve vertically and we're going to resolve horizontally. I'm going to get rid of this bit up above here because we've used it, we've got its benefit. We know that cos is equal to this. So this is my part 2. Obviously you wouldn't do this in an exam. Just to give me a bit of space to do this. Okay, right. So we're now going to have a wee go at our part 3, which was finding the reaction and angle of the pivot. So we're going to have to do this by resolving vertically and resolving horizontally. So resolving vertically, I got P cos alpha, and then also going vertically, I've got 42. It's going to be cos theta, and that equals 12g. So that means make the P cos alpha the subject. You'll see why in a wee minute. That's going to be 12g minus 42 cos theta. And when I did that out, I think I got an exact answer. I'm going to do that out again just to show it to see. That's going to be 12 times 9.8 and then minus 42 times my 25 over 28. And it gives me 80.1. It gives me, a nice answer of 80.1. One of them is going to be nice, one of them is not going to be nice, unfortunately. We're also going to resolve horizontally, and the force is right. So the force right, which is P sine alpha, equals the force left. Now the force left is going to be this one here. The 42, the amount of 42 that goes left. So it's going to be 42 sine theta. So that means P sine alpha is equal to 42 times, and again I'm checking this, 42 times, and that's going to be the square root of 159, and then that's all divided by 28, and what that gives me an exact answer of 3 root 159 over 2. Yep, that's what it gives me. Okay, right. I've got equation 1 and I've got equation 2, and this is a lovely wee trick then. So we can now move on to this. So what we're going to do is you're going to do your P sine alpha and divide by P cos alpha. So that really means you're doing your 3 root 159 over 2 divided by your cos alpha, which was just 80.1. Now look at the left hand side. P's will cancel, and sine divided by cos, you better know, is equal to just tan, and then that works out to be 0.2361. Goes on forever and ever and ever. Now you do have to find your alpha. My alpha is 13.2860727, and then put that back into equation 1. Put that back into equation 1, and you're going to have then R is equal to 80.1 divided by then cos of the 13.2860727, and your R works out to be 82.3 newtons, and there we go. So your answer is 82.3 newtons at, and then the 3 sig figs, 13.3 degrees, and I'll say to the vertical. And that's one way of doing it. Okay, right, I'm absolutely not going to go through this as well again, but just to show you what some people may have done, you may have changed the reaction, written the reaction as X this way and Y this way, but if you take my word for it, then you're going to get the horizontal bit. Your X is going to work out to be then, oh my goodness, which one was the horizontal? The 3x will work out to be 3 root 159 over 2, and your y would work out to be 80.1, and then you would have to do the same thing. You'd have to draw a wee diagram. You'd have 3 root 159 over 2, and then 80.1 there. Then you could use Pythagoras, and then you could say the reaction, maybe even do your alpha horizontally, and use Pythagoras to find your r, use trig, so tan theta to find tan alpha is equal to 80.2 over the 3 root 159 over 2 to find your angle. Okay, so you may prefer that way. This is just my preferred way of doing it. Okay, the last bit there says, what modelling assumptions have you made? I think they mentioned that the string was light. The only other assumption I could think of was that there's no friction at the hinge. Right, that was pretty rough question now, and pretty rough mechanics section all in all, I thought. Mechanics is normally fairly straightforward. I didn't think that was. Okay, section B, statistics. The gestation period for a female mammal is the duration of pregnancy. For a certain type of hippopotamus, the gestation period is normally disputed with a mean mu and a standard deviation of sigma. It is known, so let me just write that down. Here, they didn't give us much room for this question, I've just realised. It is known that 5% of this type of hippopotamus have a gestational period longer than 8.9 months. Write down one equation in this. Okay, right, first of all, probability x is greater than 8.9 is equal to 0.05. We're going to use our inverse normal method on the ClassWiz calculator. So it always uses less than's. So we're going to say probability that z is less than z1. So z1 is the normal version of the real life value of 8.9. Okay, so we're going to use inverse normal. My area, sorry, I'll do a diagram here just to show you. So that was 0.05, and that was 0.95, and that was my Z1, which is equivalent to 8.9 in the real world. But your area is 0.95. For the regular standardized variable, sigma is 1, mu is 0, and Z1 is equal to 1.64485. And then you're going to use your conversion formula, z equals x minus mu over sigma. You can see they really didn't give me much room for this. I wonder is there a nicer way of doing this? And then that is 1.64485 is equal to my x value, which is 8.9, minus my mu over sigma. And then we'll write that as 1.64485 sigma is equal to 8.9 minus mu. So 8.9 minus mu. And that will be my equation 1. Second one, furthermore, 33.2% have a gestational period of less than 7.9. So this is a wee bit easier. I'll do a wee diagram again this time. 1 second. There you go. What do you say? Close the door. Apologies. Lego emergency. Right, so it says, furthermore, 33.2% have a gestational period of less than 7.9 months. So it says, so there's my middle that would be here. It's going to be less than, so it's already in the good setup. That's going to be 0.332, and that was Z2, which is equivalent to 7.9 months as well. So in well, let's write that in here. So probability that X is less than 7.9 was equal to 0.332, and that corresponds to Z being less than Z2 is equal to 0.332. So we're going to use our inverse normal again. Squeeze this on. Squeeze this in somewhere. So inverse normal. Your area is 0.332. Your sigma is 1. Your mu is 0. Therefore, your Z2 works out to be minus 0.43440. And it should be minus if you think about it. It's over on the left-hand side of the 0, so it's going to be minus. Same boy that we used earlier on there. We used Z is equal to X minus mu over sigma. Fire that in, that's minus 0.43440 is equal to my X value. What was my X value? It was 7.9 minus mu over sigma, and then that is minus 0.43440 sigma is equal to 7.9 minus mu, and that is my equation 2. So I have two equations, two unknowns. You know what's coming. So we write down our two equations again, but what I'm going to do here is I'm going to write my equation, bring the sigma and the mu both over to the one side. I'm going to use my new function on my calculator. It's new to me, it's not new to most of you, I'm sure, but to solve simultaneous equations. So writing those down, bring them both across. Okay, if you don't want to do this, folks, you can solve these very easily. You can see you have the same number of mu's in both equations. You would just subtract really to get there. So it's pretty easy, but you can use the solve on the calculator. So on the old class whiz, let me see how I get this one. Okay, so it says xy equals 0. If you go to menu and then you click on that one, and then it's and then you click on simultaneous equations. Number of unknowns is 2, and then what comes up on my screen here, I wish I had my thing here to show you. What comes up on the screen is this. Now what you do is you hit, for the first one here, you put in here, you type 1.64485 and then press equals. 1.64485 and press equals. The wee selector then moves across to here. You type in 1 because you've 1 mu. You move across to here and it's 0. It's already at 0. Press equals again. Press 0 in just. You have to actually type 0 in. And then the next one, type in minus and then 0.43440. Press equals. So it's now shifted across to here, and you type in 1, press equals, and then sorry, notice this one here up here should have been 8.9. the first one, you can use the arrows, go back up and change that to 8.9. so it's 8.9, and I go back on through and change the last one in is 7.9 as well. So this one here is 7.9. Messed that up, but there we are. And when we do that, you get two values. So you press n equals, and it says x equals, and it was it said x equals, Rx, remember, corresponds to sigma. So it was 4,000 over 8317. And then you press equals again, and it tells you y. We're talking about, not talking about y, we're talking about mu. So mu, and it comes out as a decimal. This one is 8.10892. So this one works out to be 0.481 to 3 sig figs. This one works out to be 8.11 to 3 sig figs. Lovely. Next one says, calculate the probability that the gestation period for a hippopotamus of this type is longer than 7.3 months. Okay, first of all, let's set it up normal. We now know the mu was 8.11. The standard deviation was 0.481. So the variance is 0.481 squared. What we want to find is the probability that x is greater than 7.3. So we can use, on the World Class Whiz calculator, the normal CD mode, and that means your lower value. Do we sketch if we need to? There's 7.3. Oh, diagram's wrong, because there was my mean, remember, is 8.1, so 7.3 is going to be here. So I'm going to guess this is going to be a pretty big decimal for my answer for this area. So my lower value is 7.3. My upper, just do 9 times 10 to the power of 99. Technically this thing goes on to infinity, but my upper is that my sigma was 0.481. My mu was 8.11. I'm going to do this again. So Class Whiz, go to your normal CD mode. My lower is 7.3. My upper is 9 times 10 to the power of 99. My sigma is 0.481. My mu is 8.11. And then that is my probability that x is greater than 7.3, worked out to be, from my Class Whiz calculator, 0.954, again the 3 sig figs. Okay, lovely using your Class Whiz calculator for these. Makes it so much easier than any other method, so I wouldn't really entertain any other method these days. Okay, right, question 7. Here we go. Right, we're on to our hypothesis testing. So a sports coach is investigating a possible correlation between an athlete's reaction time and their time taken to run 100 meters. Now, I would imagine if you can run 100 meters, your reaction time need to be good, because you need to get off whenever that gun goes off. So she decides to carry out a hypothesis test and states the following. So this is the default for product moment correlation coefficient testing correlation, that there is no correlation. So your H0 is always, your rho is equal to 0. And your H1 then, she thinks that there's some correlation. She hasn't said, I think there's a positive correlation. I think there's a negative correlation. She thinks there's some correlation. Okay, so it could be positive or negative. So that's why rho is not equal to 0. And that's where rho is a population correlation coefficient. State whether this is one-tailed or two-tailed test and explain. Hard to explain, but it is two-tailed. And I've just said as it is, rho is not equal to 0. Right, I've got a mark for that. Well, I would get a mark for that next bit. I'm not honestly sure. Okay, so I think I need to wait until the mark scheme comes out to see that one. Exactly what they were looking for there. But it's a two-tailed, because it's a not equal to. It would have been one-tailed had it been that or that. Okay, that seems a lot. That's a 2 marks, seems like a lot for that question to me. Right, it says for a random sample of 18 athletes, the sports coach calculates the product moment correlation coefficient to be 0.5217. State the acceptance ratings for R. Is this in this hypothesis test with 5% level of significance for a simple sample of this size? Okay, right. Your n is equal to 18. It's 5%. Okay, right. We've got to go to our tables. Have I got my tables here? I don't. Great. There we are. I have done this already. Right. So you can see you go to your product moment correlation coefficient. It was 5%, but because, remember, it was a two-tailed, that means 0.25 or 2.5% is at each end. So you're looking here at 18.025, and what they meet up as, that's going to be minus 0.4683 or plus 0.4683. So we go back to our thing then, and we will see you can see there we have it. Same mistake again, so it's kicking off over here. 0.04683 and 0.4683. And then that is my acceptance region is the good bit, so it's not the extreme bits, it's the bits in between. So we just put those in, so we want this area in between here. So it's going to be 0.4683. If it's between that and the positive version, we would accept. Okay, next bit says, hence complete the hypothesis test. We know the R, his R was 5.216. So where does that appear? It appears in here. So that means we're going to reject 80. Okay, so that's really what's going on. So if we just do this, we just say, I'll just do that wee diagram again. That was okay, so my value appeared in here. So we can just say that was where the 0.5217 is. And I would just say 0.5217 is greater than 0.4683. Therefore, it's in the critical region. Hence, reject. It's 0 in favor of H1. So, and relate it back to the real world. Say at a 5% level as well. Add that in always. Shows there is evidence at a 5% level for a correlation of some sort. Okay, it looks like it's a positive correlation. It's on the upper end. She would need to test that again. Now making her hypothesis that it's H1 is rho is greater than 0. Right, blue-green algae is a type of bacteria which occurs naturally in open water. A microbiologist models the amount of blue-green algae in a particular lake using a normal distribution with a mean of 3.8 units and a standard deviation of 0.7. Following a spell of hot weather, the microbiologist wishes to test if the mean amount of blue-green algae in the lake has increased. He takes a sample of 60 readings from a randomly selected range of locations on the lake and finds a mean of the sample to be 3.98. Carry out a hypothesis test at 2.5% level of significance. Right. Write down how your thing is normally distributed. This is what I always do. So it's 3.8 and 0.7 squared. And then what we want to do is write down how the mean is distributed. So it's 3.8 and then 0.7 squared over my n, which is 60. And then we want to say what your H naught is. It's always, for normal, it's always about the mu. So the default is that mu is equal to 0. But he thinks it has increased. So he thinks it's now gone bigger than this. And he wants to test this at 2.5%. Okay, so I would also write in somewhere that it's a one-tailed test. If you look at the mark schemes, quite often you're getting a mark for just saying it's a one-tailed test. Now, what I would do, you're not necessarily getting any marks for what I'm doing here, but this is how I understand it. I do my diagram, I mark in the 2.5%, and then basically I'm going to decide, was my test value here or was my test value here? If it's in 1, then I don't reject 80. If it's in 2, then I do reject 80. That's all we're doing. So now what we want to do, sorry, apologies for the noise, if you can hear the noise in the background there. It's my 4-year-old kicking off. We want to find the probability that x bar is greater than or equal to 3.98. And that's what we're looking to find. So we're going to use the old class whiz again, thankfully. Normal CD. and my lower value is 3.98. My upper value, so we want to find the upper value then. The upper value is going to be 9 times 10 to the power of 99. My sigma, how you get your sigma is a square root of this. So if you square root this, you're going to get 0.7 divided by root of 60, and your mu is still this. Your mu is 3.8. So when I worked that out, I got probability that x bar is greater than 3.98. It was only equal to 0.0232. Hopefully I've done that correctly. And then you would say, so you can see now what I do, I score out this other one. You can see where my test value is. It's gone in here. So it's definitely in that region. And then you just write this up. So i.e. test value in critical region. Therefore, evidence at 2.5% level to reject H0 in favor of H1. And that's i.e. evidence that the amount of algae has increased. Done. Okay, right. Couple more to go. Yep, 2 more to go. This one, question 9, conditional probability question. It says, below shows a fuel type of a number of vehicles and whether they passed the most recent MOT test. So you can see we've got petrol, diesel or hybrid, passed or failed. Just add them all up, 207 plus 189 plus 78 plus 12 plus 16 plus 3. And I got a total of 505. Okay, so it says if one of these vehicles is selected at random, write down probably that it is diesel vehicle and field. So diesel and field is 16 out of 505, and I would, you know what, that's absolutely fine, but I would give it the 3 sig figs just in case. Now if I need to use this later on, use this one here. Next one says, given that a vehicle passed its MOT test, find the probability that is a hybrid. So we're looking for hybrid given it passed. So that's the same as hybrid and passed divided by the probability it passed. Now, hybrid and passed, you've got 78 out of 505. Let me just write that in my top line. What have I just said there? 78 over 505, and then passed then are going to be all of those in yellow there, all 3. So that's, let me just check that, that's going to be 207 plus 189 plus 78, which is, yep, 474 over 505, and then that just works out to be 78 over 474, and which works out to be 13 over 79, or 0.165 to 3 sig figs. Now just on that one, you might have wanted to just do, just to say then, my hybrid and given it's passed means you're zooming in on the past, and then that's the total of a past, and out of those it's 78. So that again would have just been, that would have been 78 over 207 plus 189 plus 78. So let me just do that. So what if I just said 78 on the top, and then 207 plus 189 plus 78. And you can see if you do that, that works out as 13 over 79 as well. But this way of doing it, to be honest, this is the way I do it the most times. I can nearly turn the brain off. I don't have to think too much when I do it that way. It makes it a lot easier. Right, this one says, a wine expert Don't ever be that guy. A wine expert claims to be able to tell the country of origin of a wine just by tasting it. The probability that he answers correctly on the first attempt is very small, but is P. And the probability of a correct answer increases by 20% after each incorrect response. The probability that the expert takes exactly 3 attempts to correctly answer is 0.102p. Using a probability tree or otherwise calculate the value of p. Right, did I use a probability tree? I'll tell you what I did. I made a real mess of this. Right, he can get it correct at the start with a probability of p. That means he gets it incorrect with a probability of 1 minus p. Then here, not correct then is going to be, if after each incorrect answer, the probability of him getting it correct increases by 1.2. But he gets it incorrect, so that's going to be, he gets it correct then, it's going to be 1.2 times p for him to get it incorrect. To get it correct then, to get it incorrect then again is going to be 1 minus 1.2p. And then after this then, the chance of getting it correct on his third go is going to increase by 20% again. So that's going to be 1.2 times 1.2. So that's 1.2 times 1.2p. That's where we go. And this is what we want. So you want probability of getting not correct, and then correct. So it's 1 minus p upon 1 minus 1.2p, and then times 1.44p. And we also know that was equal to 0.102p. Now we just start multiplying this thing out. I've done multiplied out the first 2 brackets, and that gave me 1 minus 2.2p plus 1.2p squared, and that's times 1.44p. And then if you multiply that out again, you have 0.102p, and on the right hand side that's going to be 1.44p minus 3.168p squared plus 1.728p cubed. Bring it all to one side, put it equal 0. I'll have 1.728p cubed minus 3.168p squared, and then plus 1.338p. Now you could pull a p outside of brackets. And you have this, okay, and then you could solve that and you're going to get 3 values. So sorry, we're going to solve that and we're going to get 3 values. And the 3 values, you can solve that in your calculator or whatever way you want to do it. So your p is going to be equal to 0, and then solving the next one, just do it as a quadratic here. Bear with me a wee second. Should have had this done out. What I actually did, I used the solving function on the calculator to do it, but I'll do it using a quadratic formula just here, just in case they wanted you to do it. I don't think they would. But 3.168 plus or minus the square root of 3.168 squared minus 4 times the 1.728 times the 1.338. Square root of all that, all divided by 2 times my a, which is 1.728. So that's just my minus b plus minus b squared minus 4ac all over 2a. And I'm going to assume that I had this right here. And I got 1.17, or p is equal to 0.65, and it was 0.6598. Okay, now this one is not going to have a probability of 0. So that's not possible, that's impossible for us. You can't have a probability bigger than 1, so that means your answer is just p is equal to 0.6, oh sorry, I'm going to have to check that. Apologies, I'm going to have to check this here, sorry. What was it? 3.168 and then minus 3.168 squared minus 4 times my A, which is 1.726 times 1.338, and all divided by 2 times 1.728. Yeah, I was sorry, that was right then. Apology, I did the wrong thing written down, just needed to check that there. So that's going to be 0.660 to 3 sig figs. So 0.660 to 3 sig figs. Now the reason, it says, give a reason why binomial distribution is not appropriate for this model. And if you think about what's happening, it's changing. Those values aren't the same every time they change. It started off as P for probability of correct and 1.2P. So they're not independent events. So that's the reason why binomial would not be appropriate. Okay, right, last question, here we go. Okay, it says, a sporting organisation claims that 1 in 4 sixth form students cannot swim. Jo suspects that this claim may be incorrect, so she carries out a survey of a random sample of 50 students, 50 sixth form students at her school. Jo plans to carry out a hypothesis test at 10% level to test her suspicion. State the null and alternate hypothesis for this two-tailed test. So it tells you it's two-tailed. So H is that my probability of success, 1 in 4 means 0.25, and she thinks it's different, so it's a two-tailed test, so she thinks it's not equal to that. It says the critical region for this test the critical region for this test is such that the probability in each tail is less than 5%. That is key, and calculate the critical region for this test. So first of all, before I do anything, X is distributed binomial. We had 50 people, so N is 50. Our probability of success is 0.25. And it's a two-tailed test because of what was 80 is not equal to 0.25. And it was at 5%. So that, it was at 10% level. So it should be 5% at each end. So 0.05 and 0.05. So we want to calculate the critical region, and sometimes it says, the reason I've told you is, find the critical region for this test such a probability in each tail is less than that. So less than is a key bit. Sometimes it's close to. Okay, so maybe if it was like this area was maybe like 0.051, and the X value that did that was 2, you would use 2 because that's pretty close to 5%. But this one, they've been very specific and they said it has to be less than. Right, we're going to use a binomial CD to do this. So binomial CD, when you go into binomial CD, your X is 5. I'm going to put in it randomly, X is 5. My N was 50 and my P is 0.25. Now these two bits are going to stay the same every time. I'm not going to write down binomial CD every time. I'm just going to do this once, and then I'm going to show what the answers were. So when I did that, I got probability that X is less than or equal to 5 was 0.007. Right, so that's pretty small. It's not very good. I'm going to try a bigger one then. X is less than or equal to 6, and that was 0.0. Oh, sorry, wrong thing. Reading the wrong thing. 0.019. Still not great. Probability X is less than or equal to 7 then was 0.045256. I'm going to guess that's my answer. We'll just check our 8. And 8 was 0.0916. So the 7 is the one we want, because 7 was the biggest one, which was still less than 5%. Okay, so if we call this up here, I should have labeled this one on my diagram a wee bit better. If I call this here call this CR1, I know then, therefore, CR1 equals 7. Right, now the awkward end is on the other end. The upper end, we'll call this CR2. And we're using our binomial CD. Now the x value I'm going to start with is 18. My n value again is 50. My p value is 0.25. And again, like the last one, this is what I'm going to do. I'm going to fire this into my calculator, see what I get. So that means what this tells me is probably x is less than or equal to 18 is equal to 0.971267. Okay. And then I've just randomly picked that one. Okay. And that means, therefore, the probability that x is greater than or equal to 19 is equal to 1 minus probability x is less than or equal to 18. So is 1 minus 0.971267, which works out to be 0.028733. Okay. Now we need to test another one. So that's pretty good. I wonder could I have gone further in this direction. So we're going to try probability x is less than or equal to 17. So when I did that, I got 0.945. But that means probability x is greater than or equal to 18 would be equal to 1 minus the probability x is less than or equal to 17. Okay, which would be 1 minus 0.945. And if you do 1 minus 0.945, you get 0.055. Okay, pretty darn close, but it's too big. All right, so that's not going to work for me there, unfortunately. All right, so it's going to be too big. It's not going to work. So my answer, my critical region then, is x is greater than or equal to 19. So x is greater than or equal to 19. So that's what I want it to be. So your CR2 is equal to 19. Overall, then, your critical region is the following. Overall, you would say your critical region is, I just say critical region is x is less than or equal to 7, or x is greater than or equal to 19. Right, the next one, and this is really need to know your notes. First one says, using your answer to part 2, find the actual probability of incorrectly rejecting the null hypothesis. So this is just what is your critical region percentage. So remember look at what they were. I'll highlight them in blue. So probability being greater than 19 was this, and probability being less than or equal to 7 was 0.045256. So the chances you could be in here, something could be in here and be a fine result. It's absolutely grand. It just happens to be very big. Likewise, something could be in here and be an okay result, but it happens to be small, but it doesn't really mean anything has changed. It's a bit of a freak result. Okay, so your critical region really is the probability of you incorrectly rejecting H0. All right, as well. So you add those two things which were in blue, which were 0.045256 and 0.028733. So we'll write those in. So my answer is just going to be equal to 0.045256 plus 0.028733. Do those out, you get 0.073989, which is, as a percentage, 7.40%. Okay, last question exam, we made it. It says results of Joe's survey show that 17 of her sample of students cannot swim. So 17, where is 17? We'd work these critical values out. Right, let me just butcher this a wee bit. We'd work these critical values out to be 7 and to be 19. So 17 is in here, not in the critical region. So let's just write that up. So just say not in critical region. So a good word to use is insufficient. Evidence at 10% level to reject 8.0. So not enough evidence to suggest difference in the number who can swim, in the proportion that can swim, I would say. There we go, lovely, and that is it done. Check over your paper, that's always a good thing to do at the end of the exam, and that is us done.